Hello everyone, my name is Oluwaseun Oyekola from Cape Peninsula University of Technology in Cape Town, South Africa. The title of my presentation is Qualitative Assessment of Biodiesel Produced from Primary Edible or Wastewater Sludge. In addressing the current global energy and environmental crisis, the advantages of using biodiesel in place of petrol diesel have been widely demonstrated. The food versus fuel dilemma, however, still persists. Food-grade canola oil has been identified as an ideal feedstock for biodiesel production, owing to its suitable fat content and low cloud point. However, a large amount of sludge is produced during the oil processing. This is associated with disposal challenges as the conventional disposal route is landfill. Landfill sites are finite and there are other potential sources of environmental pollution, secondary pollution, such as greenhouse gas emission and leachates polluting the soil. Another associated challenge or bottleneck that deters commercialization of biodiesel production is catalysis. Conventional homogeneous catalysts such as sodium hydroxide often result in saponification when low-cost feedstocks are used for biodiesel production. The wastewater sludge obtained from canola or processing plants contains high concentrations of oil. In this study, it was therefore hypothesized that this sludge may be a suitable feedstock for biodiesel production, hence addressing the feedstock and availability challenge. This forms the aim of this study. The objectives were therefore to produce biodiesel from the wastewater sludge using heterogeneous catalyst. The catalyst used was obtained from mineral processing waste. After producing the biodiesel from the wastewater, these were then compared with biodiesel from pure canola oil and commercial petrol diesel. These were as the performance and the quality were assessed for these biodiesel and diesel products. In order to achieve the objectives, transesterification method was employed for the biodiesel production. This was mediated by heterogeneous catalysis at optimum reaction conditions. The quality of the prepared biodiesel samples were tested in accordance with the ASTM methods. Their performance was tested in a stationary and computerized 4-stroke 5.2 kilowatt water-cooled single-cylinder internal combustion diesel engine in terms of mechanical and thermal efficiency and greenhouse gas emissions. The greenhouse gases that were focused on were carbon monoxide and nitrogen oxides. Results and discussion. For the selected thermophysical parameters measured in this study, it was clear that both the edible or wastewater sludge biodiesel and pure canola oil biodiesel were comparable to the commercial diesel in terms of the quality. The parameters largely fell within the ranges specified by the relevant ASTM standards as shown on the table. If you look at the viscosity, the density, the HHV, and flash point, values, you see that these are comparable for the biodiesel samples and the commercial diesel. Furthermore, the mechanical efficiency and the thermal efficiency were also comparable for the biodiesel samples and the commercial petrol diesel sample. The specific fuel consumption of commercial diesel was lower than that of, if you look at this figure here, we'll see that the specific fuel consumption for the commercial diesel was lower than that of the pure canola oil biodiesel and the edible oil wastewater sludge biodiesel. And these were within the range of brake power outputs applied, that is 2.1 to 12.8 kilowatts. The commercial diesel performed notably better at higher brake stroke. If you look at this, we'll see that at higher brake stroke, the commercial diesel performed better. As engine speed increases, fuel combustion improves. This is due to more efficient mixing of fuel and air. In this study, the engine was operated for the same duration and under the same load for each of the fuels tested. So emission changes were assessed using the engine speed. Combustion of biodiesel typically results in higher NOx emissions in comparison to petroleum diesel. However, for the current study, the measured emissions for all fuels decrease almost linearly with an increase in engine speed within the range tested. Further, the test engine emitted remarkably lower nitrogen oxides when operated with either the edible or wastewater sludge biodiesel or the pure canola oil biodiesel in comparison with the commercial diesel. In most cases, the carbon monoxide was also emitted when the engine was operated. Lower carbon monoxide was also emitted when the engine was operated with the biodiesel samples as compared to the commercial diesel sample. In conclusion, edible oil wastewater sludge proved to be a suitable feedstock for biodiesel production. Hence, this can be used as in conjunction with oil seeds. This can be used as feedstock for biodiesel production for in situ production in edible oil facilities. Overall, in terms of the performance and the quality, the biodiesel samples were comparable with that of the commercial that of the commercial diesel. The use of biodiesel can either be Hence, the biodiesel can either be used alone or blended with commercial diesel, and this promises to have positive financial and environmental impact for the transport and energy industry. Our appreciation goes to the Cape Peninsula University of Technology for this opportunity, and the WRC, the Water Research Commission of South Africa, and the Council for Scientific and Industrial Research for funding this project. I'd also like to appreciate the co-authors of this project. Thank you all for listening.